This video will demonstrate my mood tracking smart mirror project. This is half of the Sensing and Internet of Things coursework. The other half, the ISS tracker, will not be examined because it is publicly accessible. Removing the mirror panel shows the smart mirror UI. I will disable this to demonstrate the code. Running the main.py file in debug mode shows the OpenCV video stream on the LCD panel. The pink rectangle indicates where a face has been detected. This frame is then fed to the neural network. Once 10 emotions have been classified, the data points are then saved to a CSV file locally. Every hour, the CSV dataset is uploaded to an AWS S3 bucket for backup. These scripts run continuously behind the mirror UI. The smart mirror is powered by the mains. A 12-volt power supply powers an LCD driver board. A 3-amp 5-volt step-down converter drives a Raspberry Pi 4, which is plugged into a Raspberry Pi cam, and the HDMI is plugged back into the driver board. There are 5 Python files. The first one loads a training dataset from Kaggle, processes it with multithreading, splits it into training and testing data, and normalizes it, and saves it as arrays. Here are some examples of the dataset. The second Python script loads the arrays and builds a neural network with 3 layers. It trains the network on the data, and this took around 3 days. The network model and weights are then saved locally. The third Python script simply tests the testing dataset and returns the accuracy, which was around 66%. The fourth Python file runs continuously on the Pi itself. It loads the model, loads the emotion data.csv file, or creates it if it cannot be found, and enters a while loop where it returns the OpenCV image feed. Should a face be detected, it is cropped, resized to match the training data, and fed to a neural network. The numbers returned from the network represent the probability of each emotion. This is saved to the CSV as a new data point, along with the date, time, and the maximum predicted emotion. The final Python file uploads a CSV dataset to an AWS S3 bucket. This is run as a cron job every hour. The Pi runs an Apache Webserver, which allows devices over the local network to visualize the data. The JavaScript dynamically averages the data depending on which timescale is chosen by the user, allowing them greater insights into the data. The user is able to choose how many data points they wish to display. The chart.js library allows the user to hide different data plots. This allows them to track individual emotions. The live readings page demonstrates the readings as they are taken in real time, without any processing. It has the same functionality where the user can choose the number of data points to show. The raw data page simply shows the CSV data where it can be downloaded. There is also a link to GitHub. Here we can see the live readings graph updating in real time with new data points. There is a slight delay. I will now demonstrate the mirror's UI. As you can see, it is showing a live stream and data from my 3D printer using Octoprint. It shows my web calendar, weather data from the Open Weather API, and the Bitcoin price fluctuation. It also shows the service of the London Tube Lines using the TfL API, the BBC News RSS feed, and I've linked it to my Spotify account using the Spotify API. Alexa, turn mirror on. Alexa, next song.